I'm going to speak briefly about sort of the potential to develop a glulam market here using those local species. And then we have Lance Gloss with the Conservation Fund. So they've provided a bit of support for the certification and sort of market development of glulam. And so he's going to talk from a funder perspective and from their perspective, the benefits of this kind of a project. And lastly, we're fortunate to have Chris Stearns from Hanson Bridge, who's a bridge manufacturer, and they're sort of stepping up and getting certified using local species to use in some of their projects. So he's going to talk about, again, from their perspective, what they're doing, what they see as the advantages and what have you. We're trying to keep it, we're a little behind, but, we're going to try to keep most of these presentations pretty brief and then save a bunch of time afterwards for sort of a Q&A/panel type discussion, if that sounds good. I think this can be pretty informal, so if we're not clear about anything as we're going through our presentations, feel free to stop us. I think the most important things, you're getting what you want out of this presentation, so if we're using jargon or anything like that and you're going, wait, what's he saying? Just stop us, and we can go down that rabbit hole or answer your questions. So that's about it. So again, we're just going to start with Ricky McLean from Mass Timber Advisors, and he'll lead us off. It's just for the, yeah.
All right. Hello, everybody. Good morning. As Andy mentioned, my name is Ricky McLean with Mass Timber Advisors, which is about a 5-week-old company. So it's good to be with you here. Thanks. My background's in structural engineering. I live in Woodbury, Vermont. I've been in Vermont for about 16 years. And prior to that, lived in Maine, went to the University of Maine. Structural engineering is my background. So I worked for a structural engineering firm in Montpelier for about 7 years. The past decade or so, I've been working for a national nonprofit in the wood industry called Woodworks. And so I worked on hundreds of mass timber projects in the U.S. through that process. And then, like I mentioned, just about 5 weeks ago, started my own company. And I focus on consulting on mass timber projects, as well as consulting for mass timber industry, so potential new manufacturers, software technology companies, anybody looking to enter or broaden their presence in the mass timber market. And then I do a little bit of structural engineering work here locally as well. So I'm going to focus on glulam. It's interesting in the write-up I noticed, I think it was very well written for this session, where when we talk about mass timber, most of the focus is on a product called cross-laminated timber. I think we did a session about CLT cross-laminated timber at this event last year. But glulam is as necessary to a mass timber building as CLT is. It gets a lot less of the focus perhaps. But that's what we're going to do is basically, in my session anyways, we're going to kind of introduce you to glulam. What is it? How is it being used now? And then talk more specifically about local species in a minute. So this is a picture of a very traditional, if you will, modern mass timber building. And if you look, there's glulam all over the place, right? All of the exterior columns, the interior columns, the beams, the purlins, all of this is glulam. And then above that, you can't quite see it, but above that would be some type of a deck like cross-laminated timber, dowel laminated timber, nail laminated timber, etc. But it makes up kind of what I call the structural skeleton of any type of modern mass timber building. By volume, usually about 30 to 40% of the timber in a mass timber building is glulam. So the greater volume is taken up by the decks, and that's just purely due to the fact that they exist over the entire deck surface as opposed to isolated members, which are glulam. But usually about half of the cost of a mass timber building or the timber portion of it is tied up in the glulam itself. So what exactly is glulam? I've got a couple samples here. Maybe it would make sense to just pass those around too as we look at it. The big one, the big one that Andy's passing around here, that is a glulam product. It's used in a unique application, or it's used in a plank application. So glulam is basically taking, in the most cases, just commodity 2x wood products, laying them flat, and then laminating a bunch of them up on top of each other to form a member like this, which is more of the smaller cross-section that you see there. That's just 2x4 glulam. I think it's 5 or 6 plies deep. So that's obviously a very small glulam. Typically, they would be much larger, but for the purpose of hauling around a sample, that does the trick. The other one, the bigger panel there, is actually just 2x2 wood laminated together, and that can be used for things like a structural wood deck on a floor. That actually was Insider Baseball. That was some of the cutoffs from a gentleman that lives in Moortown, built his house recently, and that was some of the cutoff. That was his floor decking. So if you look at both sides of it, there's a very nice looking side and there's a not so nice looking side. So that would actually be used where the nice looking side is face down, because that's what you see from underneath. And then there's a finished floor applied on top. But that is a glulam product. It's a bit of an untraditional glulam, but it is a glulam product. So it's used in, like we saw the picture a few minutes ago, beams, columns. We'll look in a few minutes, arches. Arches was actually one of the first uses of glulam in the US. You see a lot of like older schools, gymnasiums, libraries, cafeteria with glulam arches. And then it can also be used in trusses. I think the last picture that I have in the presentation is a building just completed a couple months ago in New Hampshire that used 210-foot span trusses that were primarily glulam shapes. So the first, going back from what I could find history-wise with glulam, the first patent on glulam was actually received in 1901, and that was in Europe by a gentleman there who was, I forget the exact, I don't think I have the terminology here, but it was essentially how he described it was several wood laminations bonded by glue, or something like that, to kind of describe what is glulam. He inspired a lot of interest in it in Europe. There was a gentleman that came over from Europe in about 1920, and he tried to get some interest going in the U.S., didn't have a whole lot of luck for the first decade or so. Finally, in 1934, he had a construction company, got a contract to build a school gym in Wisconsin, and that was the first project in the U.S. to use glulam. They had a lot of pushback from the authority having jurisdiction, the building officials basically, because they had no idea what glulam was. It had never been used in the U.S. before. So they made them take these really nice glulam arches and reinforce them with a bunch of steel. Of course, ultimately that wasn't necessary, but that's what they had to do to get the building permitted and approved. So that's one of the first shots of the glulam arches being fabricated. This is that first building, that school gym, which, by the way, was built in 1934. It's still standing today. It was converted to a library at that same school in the 80s, but still functioning really well. So 90 years. Glulam's been used in the U.S. for 90 years. Pretty cool history. This is just kind of showing you all of maybe the non-traditional mass timber building, like I showed at the beginning. These are more of the non-traditional mass timber uses, but still very traditional glulam uses, showing you the arches, curved shapes, doubly curved shapes. I'm working with a contractor right now who's working on an amphitheater project in California, very complex, doubly curved glulams. So you can do a lot with the material for sure. In terms of the species that are traditionally used in glulam, it's really all of the same softwood structural species that we see used in 2x studs. And again, that's just because you're starting with those materials and then laminating them together. So southern pine, Douglas fir, spruce pine fir are some of the most common. Cedar is a common use when glulam is used in exterior applications. You can either pressure treat like a southern pine or use like a cedar product for exterior applications. We're going to focus a little bit and maybe get a little geeky, like I like to do sometimes, on how and why we might have different strengths of products. Does somebody know where some of those samples ended up? They're over there. I'll take the smaller one, please. So if we were to look, thank you. If we were to look at this, so this is 5 laminations deep, right? And it depends on the application that we're using a glulam in. If we're using it for a beam versus a column, we might want to have different laminations. And the reason is, I'm certainly not strong enough to actually bend this thing, but if we were to think of this thing being, let's say it's a beam holding up the roof or a beam holding up the floor, obviously we have weight in here that's putting load on it that's going to want to bend that beam. So the structural stresses in that beam are actually highest at the top and at the bottom. So it makes sense to have highest grade lumber at the top and at the bottom for beams versus for a column. All of the stresses are the same throughout the size of that entire column, so using something that's more uniform makes sense there. And then the other sample there, it makes sense to have the same species and grades throughout because that's oriented flat-wise, so it's going to be the same load across the entire thing. Right, yeah. Thanks, Andy. So this is just looking at, this is a Douglas fir glulam. This nomenclature here, 24FV8, is just a way to identify some of the properties about the glulam. Won't go into the specifics here, but it kind of shows you, if you were to look at a traditional glulam, a Douglas fir glulam, how would the different laminations stack up throughout that? So we're going to look at what does A, D, E, all that stuff mean in just a second. But first I wanted to kind of show like those differences that I mentioned a minute ago. If it's a beam versus a column, what is that? How do we optimize where the different strengths of lumber go? And as we think about the potential use for local species and local grades, that really is amplified because, what is the availability of all these different grades? What's the practical nature of a balanced beam versus unbalanced versus uniform layup? Because ultimately that feeds into what might be the best end cases or applications for local species that are going into glulam. So just a little bit to show you where might each of these be used best. So this is a balanced beam, basically meaning if you were to cut this thing right in the middle, what's on the top is exactly mirrored from what's on the bottom. It doesn't mean that it's uniform throughout, but you can see A and then D, A and then D, and then E. So it's exactly the same layup throughout. And what that is used best for is a beam that basically spans over multiple posts. And the reason, because if it's just a beam that spans from one post to the next and the beam is cut there, it's always going to be bending. Like if you were to look at the deflected shape of that beam, it's always kind of like a smiley face, right? It's always in that direction. What we're really trying to do with the glulam is, I mentioned the stresses are highest at the top and the bottom. We're really trying to get the highest where the tension is, right? If you bend something like this, the top of that is in compression and the bottom is in tension, right? You're trying to pull the bottom apart, compress the top together. So if it's doing this, basically the deflected shape would look something like it goes down here, then it goes back up here, down here, back up there. So it has tension at both faces, depending on where in the span you are. So that's why you would use a balanced layup. You want that high tension capacity at both the top and the bottom of the beam. Versus if it's just a simple span, like we said, between one post and the next, doesn't extend beyond, it's always going to be that smiley face. So the bottom is always going to be in tension. So this is an unbalanced layup, where we have the highest strength, highest tension strength laminations at the bottom. The top is still a higher grade sometimes, but it's not as high as that very bottom.
You just make sure you put it in the right way.
Yeah, they do come stamped with top on the top, and I have seen beams installed where you look up and it says top, and it's like, that's not the top of the beam. So yes, labeling and then proper installation is key. And then a uniform layup, like I talked about, a column, that sample over there, something where you're using it in a plank orientation or a column orientation. You certainly can use this in a beam orientation, and I'll show kind of the relative differences in properties, but this will have a little bit lower capacity than, say, a balanced or unbalanced beam, because you're using that same core lamination throughout the entire depth of the beam. It still has advantages over, say, just a rough sawn member, but potentially not as high as a balanced or unbalanced beam. So this is showing what those relative differences are. It's like, this is basically saying if we just take, and this is all based on Douglas fir, but we could do a similar comparison for other species and the relative differences would be the same. So if we just take a solid sawn beam, we cut down a Douglas fir tree, we cut out a section, roughly, this is number one grade, roughly 1,350. This is how much from a bending perspective this can take. So the higher the number, the more load it can take. So 1,350 for that. And then you see once we start going to glulam, now we're up to 2,100, 2,400. So this is kind of showing you those relative differences between balanced, unbalanced, and just the beam itself. So even if we just look at a uniform layup, it has a significantly higher property than, over probably about a 60% increase compared to just the straight beam. So certainly an advantage to be able to lay up, even in a uniform pattern, a species compared to just having a solid sawn member.
So if you took that beam, zipped it, glued it, then you'd be there.
Potentially. The couple of the reasons why there are these differences is the smaller the specimen of wood, the less likelihood that there are imperfections that are impacting the structural properties. Because, for example, like knot size, wane, pitch, those things, they're respective to the size of the member. So there's limits on the sizes, the smaller the member is. So taking that into account, you have a bunch of small pieces, the imperfections on each are smaller, therefore when you lay it up, your net property is higher. So that's the main reason. So to answer your question, probably not, because this large solid sawn member is allowed to have larger imperfections, if you will. So the chance that any one small slice from that is going to have a large imperfection are higher.
So the glue doesn't really have too much to do with the strength.
Not a whole lot, no. No, it's mainly the properties of each of the laminations. I mean, the other advantage too is obviously you can create much larger sizes with a glue lam, right? Talking with Chris. And longer, yeah, because they're finger jointed, exactly. So yeah, there's a couple of benefits there for sure.
Smaller trees as well.
Right, smaller diameter trees, because you don't need, large column, large tree, you don't need a large tree to do that. All right, I'm going to speed up here so I don't take up too much time. I think we talked about this. Just to go back to when we were looking at, like, if you were to use different laminations throughout that, you'll start to see things like 302-20, N1D. Like, this is not something, if you go to your local lumber yard and you say, I need a 302-20 stud, right, they're not going to be able to supply that to you. It's basically starting with #1 grade lumber and having additional requirements. So for example, like a 302-20, it's a #1 dense lumber product with additional requirements for allowable knot size and location, allowable slope of grain, those types of things. Basically, it's going back to your question about why is there differences. The more imperfections you take out of the lumber, the higher the strength is. So this is just weeding more of those imperfections out, if you will. N1D is just #1 grade dense lumber. N2M is #2 grade medium density lumber. So this, for most intents and purposes, is just a #2 grade stud that you would find at your local lumber yard. How do we actually manufacture glue lam? I've got a few pictures and I think 1 or 2 videos to show you. Basically, it's the process of, I'm going to show most of these going forward, so I won't dwell on this slide. If anybody's interested in a PDF of the slides, I know I talk fast, so I'm happy to share that too. So basically, it starts out with just, again, traditional lumber or maybe high-strength lumber, but stockpiling a bunch of that. This is a glue lam manufacturing facility in upstate New York, kind of showing you the scales of the input lumber that goes in. The lumber is kiln dried. The glue lam manufacturing spec says that the lumber has to be 16% moisture content or less at the time that it's manufactured, which is a little bit less. Traditional lumber is dried to 19%, so you do have to dry it down a little bit further, specific for the use in glue lam. Lumber is finger jointed. There was a comment earlier about you can produce longer products, and this is why, because each of the laminations in glue lam is finger jointed, meaning you might start with a bunch of 8, 10, 12-foot pieces of wood, but you use those and finger joint them to create a 40, 60-foot long glue lam member, and you don't have to worry about the structural impacts of having just butt joints between those laminations. So it's finger jointed. Then it's put into a press. So this is a curved member. Obviously, they can be just straight members as well. Sometimes these are screw jack presses. Sometimes they're hydraulic presses. Sometimes they're vacuum presses. Basically, it's some means of putting pressure on these members, and it depends on the glue type that you're using, what the cure time is. But that's the process. This here is that same facility in New York. You can see these are just rails on the floor, and what goes into those is, you can barely start to see. I know if I stand in front of the screen, I'm going to block you, but I guess that's not going to show up. Over here and over here, these are movable screws. So basically, they slide along those rails. They put the wood members in there, and then those come together, and it's a screw press, basically, to hold those in place while the adhesive is curing. I think this is a video. I'm going to try to play this real quick. Let's see if this works. Nope. I don't know if I have a mouse. Oh, there we go. Let's see if this works. I guess there's no sound, but that's okay. So this is a planer. So they're passing this glue lam through the planing machine from one side to the next. It's a bit of a unique process for this one here because this is a curved glue lam, so they're kind of having to push it through and turn it as it goes. But that just shows you can see the guy in the back. He's got, basically Steering it, exactly, yeah. So if you look closely, you can kind of see the top surface of that glulam before it passes through the planer. You know, it looks fairly rough. And there's different appearance grades that you can get for glulam. Like, this would be fine for a header in your garage, right? But it probably wouldn't be fine exposed for your school gymnasium. So that's how those things are varied, is by the planing process and the appearance grade.
So this would be like Unadilla?
Yeah, that's who that was from, yep. Tolerances, they're fairly tight specs on tolerances. So this shows you, like when you're creating a glulam member, the width needs to be plus or minus a 1/16 of an inch. These are engineered wood products manufactured to fairly tight tolerances. These are all things required by the production standard for glulam. And then standard sizes of members, basically, it's just a function of how many of these things are you laying up together. Typically, you're starting with 2x4, 2x6, 2x8, et cetera, and you plane it down a little bit, which is why, you know, a 2x6 might end up at 5 1/8, for example, as opposed to 5 1/2, because you start with 5 1/2, but then you plane it down. You can create larger members, so you're not limited just to a 2x12 width. You can do where you have multiple layers that kind of stagger in the same line, or just something called block glued, where you have another one of these, you just put it next to this and you glue between them and you press that. So that's called block gluing. This is a very large block glued. This is a column so the world's tallest mass timber building is in Milwaukee, and that's where I'm standing right there, is in the lowest level. It's 19 stories of timber, and I'm in the lowest level of timber. So that's a glulam column that's about 3 feet by 3 feet. So that is clearly a block glued member to get something that large.
Does that go the whole 19 floors?
It does, yep. And there's actually 6 stories of concrete underneath that. But that is a multifamily project. Real quickly on fabrication, so you have this member, but then you need to do something with it sometimes to be able to accommodate connections and fasteners between members. So what I would call the low-tech fabrication method is basically, routers, chisels, things by hand. Medium tech is using some type of you're still using, hand methods to do it, but tools, more automated tools, something like this. And then the high-tech method is, robots, Hundiggers, CNC machines, where you're programming a CAD file into the software that runs these systems. I tried to get a video, but it didn't work here. But anyways, they're pretty cool if you're interested in seeing how this fabrication works. And then when you have these members come together, there's usually a lot of steel products, like you see here, ultimately that are concealed by the wood. So the wood is usually protecting those from view for aesthetic reasons and for fire reasons as well. And then this is what you end up with. So this is that same beam, remember we saw, that was going through the planer, and the top side looked fairly rough. This is what it looks like afterwards. Really beautiful product. And then from those things, you can create really beautiful structures. This is an airplane hangar in New Hampshire, and these are 210-foot long glulam trusses to span the entire airplane hangar. It's a pretty cool project there. All right, that's all I have. I'll pass it on to the next speaker now.
So any urgent questions, or we need to save them for?
Yeah, it's just a really quick one. You mentioned the 60% humidity in the wood grew up. What gets glued up? Is that driven by the glue needing the wood to be dry, or driven by not wanting the wood to twist as it further dries out?
It's a requirement. I'm not sure if you want to use that, but you can. It's a requirement of the production standard. So I think primarily it's driven by a couple of things, not necessarily related to twisting, but related to dimensional stability of the product. So the lower the moisture content is, the less you're going to have dimensional change later, as well as bonding of the adhesives too.
Thanks. Sorry to get in your business. All right. Yep. So it's always both nice and intimidating following Ricky, because I think he does such a good job. So it's like I could listen to him all day, but then you have to listen to me. But this is good stuff. So I'm going to talk a little bit about glulam opportunities using local species here, some of the opportunities, challenges, and kind of what we're seeing. So just want to step back in terms of context. A lot of this is what Ricky already mentioned, but currently manufactured primarily from from Douglas fir and southern pine. You know, there's some SPF, spruce pine fir. You know, I guess the goals and benefits of using local material is, you know, benefiting that whole supply chain. So right now, someone, you know, producing glulam here could buy Doug fir from somewhere else, from the Pacific Northwest, get it sent over, you know, produce a product and sell it. If they're sourcing locally, that material comes from a local sawmill. That sawmill benefits. They have a market that's harvested by a local logger, right, who has another market, or who has more demand, I guess, for their product, helps the landowner that's selling that material. And then also manufacturers, you know, so Chris could speak with this about this better, but manufacturers kind of source this local material, so they probably have a little bit more control over timing, less transportation, and so on. So viable species, you know, these are softwood species, as Ricky mentioned. So 2 and better. And so that, I think, is something really important. Sometimes with some of these engineered wood products, folks will go, oh, it's a great new low-grade market. 2 and better is not, yeah, low grade. So it's a great market. It's just, you know, we should think about this as sort of normal lumber, not industrial or low-grade lumber. And so around here, what we could think of as those local species we could use is spruce pine fir south. So I think most of you are pretty familiar with this, but there's species groups that are, you know, a number of species that go into these species groups. Spruce fir grown in the U.S. and some additional species grown in the U.S. is called spruce fir south, spruce pine fir south. If it's grown in Canada, it's spruce pine fir. Because there's a couple differences in terms of what species go into that group, that spruce pine fir, the Canadian grown spruce fir, tends to be a little bit, or when they've done testing in the wood strengths, they've said or shown that it's stronger material. A consequence of that is a lot of people just naturally, like when, you know, an architect, engineer, whoever, let's blame Ricky. People like Ricky, no, will, you know, when they're specifying something, they go, oh yeah, spruce pine fir. And so they'll end up specifying, because most people aren't thinking about that, they'll just automatically specify the Canadian spruce fir. And so the domestic mills selling domestically grown spruce fir coming off maybe some of your properties, that has less demand, could have lower pricing and so on.
So you buy your logs in the US, take it to Canada, mill it. What is it called then?
Spruce pine fir south. So it's where it grows, and those.
So that's on those plants to say, this is where this would go.
Yeah, they have to separate domestic or U.S. grown spruce fir and those species group
I'm just
and Canadian.
I mean, there's a pretty good chance to just blend it all together. And
Yeah, they can't. They're not supposed to, and I'd say they'd run into some issues sooner rather than later if they were doing that. Yeah.
I mean, there's just an awful lot of our, you know, New England wood going north.
Yep. Yeah.
Comes back.
Right, but I think in my mind, at least when I have talked with folks about this, you know, I think one of the big issues is just most consumers don't know the difference.
Right.
So it's a demand issue and even a pricing issue. So the more we can educate consumers that, hey, you know, if it's good enough for a stud, get spruce pine fir south, or if you want domestic, you know, U.S. manufactured wood or U.S. grown wood, specify SPFS. You don't have to do SPF.
SPS.
Yeah, S, so south. And then, but there's also, you know, as you mentioned, some of our domestic mills, you know, saw both. So it's just the landowners may not benefit from SPF that's sold, or U.S.-based landowners, and don't want to go too much into sort of, you know, that battle with Canada. So, you know, it's a regional economy and so on, but just wanted to point out those differences. And then eastern hemlock, and this is the underdog, but eastern hemlock can be dried and can get put into glulam. And, you know, so we're trying to sort of look at the right applications for that material, and we could talk about that. Again, current manufacturing's mostly in the Pacific Northwest and the South, close to where that supply is, and then a little bit up in Canada. And then there's some regional manufacturing, and that tends to happen when those manufacturers are selling higher value products or higher margin products. So if there's more customization and things like that, there's more opportunity for manufacturers here to kind of carve out a niche. Where if it's just a commodity glulam product, you know, the South Pacific Northwest currently is the place where all that's manufactured, or Canada to some degree. So the big thing we're kind of thinking about, so we also just mentioned, you know, there's an assumption, and a great assumption. They're entirely right. If you're making, as Ricky pointed out, you know, if you're making a beam, that's going to reflect the design values, the strength characteristics of the wood you're using. So if you make a beam out of spruce pine fir south, we know it has lower design values, less strength. When you glue the same amount of same number of, you know, boards together, same number of laminations, that's going to have less load-bearing capacity, if that makes sense. So that's the assumption, and so oftentimes folks go, oh, we can't do that. We can't make, you know, we can't do glulam out of local species because it's not strong as these other species. Does that make sense? So that's entirely valid to sort of approach it that way, but what we're looking at is trying to understand if it's strong enough for the use, right? So we can manufacture something that's not as strong, but can it occupy a niche and can it serve a specific role? An example would be we all go to the store, right, and buy our stud. Very rarely, I bet, any of you go into your big box store, look at a stud and go, you know, I want to make sure this is the strongest stud here, right? You'll see if it has some warp, because that doesn't fit the function you need the stud for. And you know the stud meets the minimum strength requirements for what you're using it for, so you get the stud, right? And so it's the same idea here. It's a little different, but that's the idea. Right now, everyone's going into the store and saying, we need this will never work, we need the strongest wood. That's fair, but there's an application for these local species where it's strong enough, and in those cases, we can carve out a niche. That's the thesis, at least, that we're working through.
Could you comment on the differences amongst glulam, microlam, and whatever Macmillan Blodell calls their version?
Do you want to handle that one?
Yeah, I'm not sure about the last one you mentioned, but the microlam is a product called LVL, which is laminated veneer lumber, and it's slicing down wood to small veneers, you know, 1/16, eighth of an inch veneers, and then laminating those together. So that's the main difference, is whereas this glulam is using 2x-dimensional lumber, that's using veneer-based products. From a structural standpoint, they're fairly similar properties. Like an LVL, because you're slicing it down even smaller, small properties, less defects. Usually, let's compare just numbers-wise, 2,900, 3,000 is the allowable bending versus a glulam 2,400. So it's a little bit lower properties, but we can use local species in glulam where we might not be able to in something like an LVL. Oh, PSL, yeah, parallel strand lumber. Similar to LVL, yeah. You're not using like sheets of veneer, you're using small strands of lumber. But again, you're breaking it down into very, very small pieces and then laminating it together.
Thank you. Yep. So again, just like we heard this morning, you know, these are, I think of them as new old products. Been around a long time, but it's still, you know, coming back to it, and that can be difficult, new product development. So everything's not, you know, totally perfect and ironed out, but we're sort of working through that process. How it's being used, and then making sure that the material can match the function. And in some cases, it's not going to be the right material for the use. So how it's being used, just to reiterate what Ricky mentioned, you know, so beams and columns, but also in other structures. So oftentimes when we're thinking of glulam, and many of us, you know, we're thinking of engineered wood, we go immediately to buildings. But there's also kind of bridges and other structures that aren't just buildings that can use these structural supports, glulam supports, and then also things like decking and other non-load bearing uses. So something like crash barriers. Northern Border Regional Commission has a grant out around timber for transit. This would be, I think at least, or we hope this will be a perfect application for those kind of grants, right? Local glulam for for those kind of functions, and it should work pretty well, we think. All right, so what's a viable glulam manufacturer look like? You know, when we've talked about this, I think most folks assume it's going to be part of a large CLT facility that would get set up here. So high volume, low cost manufacturer, CLT manufacturer that, and a lot of those CLT manufacturers have glulam lines. So I think that's what most people envision when we talk about glulam, but what we're seeing is that there are some smaller businesses that are sort of have unique attributes about the product they're selling where doing their own manufacturing, glulam manufacturing at a smaller scale can make sense. And that's because they're vertically integrated, they have higher margins, potentially, they can kind of control the supply of what they're trying to produce. And some of those sorts of things. So we have, you know, a couple people that are trying to get certified now with these local species. But, you know, we also need to make sure when we're talking about this and trying to develop the market that it's not just a pipe dream. It always has to come back to being a competitive, a cost competitive product in the market where it's functioning. And so we're constantly going back to that. Can this be competitive? How do we make it competitive? What are the uses? What are the niches? And supporting those businesses in those applications. And then more entrepreneurs and smart business people understand how to adapt and scale that into other areas. So how are we trying to support some of these efforts? Well, it's really supporting, I mentioned before, you know, new product development, really difficult. We heard about that earlier. A lot of different actions we're hoping, which in aggregate will support the development of this market. So at its core, it's supporting demand in markets. So currently, with glulam, all the specifiers, just as we talked about SPF, you know, people automatically go, oh, we should have SPF studs. All the specifiers, or most of them, as I've seen, tend to specify Douglas fir or southern pine. And so we're in this chicken and egg scenario where we're trying to develop a new product, or a product with a new species, different species that's not being used, but no one would know about it or specify it. So how do you get the demand, right, for this product that's, why would someone specify a product that's not being made right now? Oh, yeah, Marina.
I wonder if you see like the Buy America requirements helping.
I don't necessarily think so, because they'd get the southern, it could, but they could get that certification for southern pine and Doug fir. So it would still be, currently it's domestic, but it would push out the spruce pine fir glulam. So
That could help if the construction project has also CLT in it. Is if you have difference in species, it looks visually different. So if the columns look different than the panels, and people go, oh, this looks different, I want it all to look the same.
yeah.
There could be an advantage there.
Yeah. So right now what we're trying to do is at the same time as you know, folks are getting certified, we're trying to help work to revise standard plans. So standard bridge plans, standard structural plans that towns can pull off the shelf for those kind of situations where they're putting in a new building, or NRCS has farm buildings that they put in where they have glulam. If New Hampshire, Vermont, Maine, NRCS can integrate those local species into those plans, then we have some sort of demand draw, right? So people know they can specify this at the same time that people are getting it certified. But basically getting the demand and supply going at the same time. Difficult, but that's the effort.
But
yeah.
I don't know if you or even Ricky, rather than the plans stating the species, just state the performance that the glulam has to meet. And that way it's agnostic of it as long as you meet the performance, because that's ultimately what it matters is it strong enough, is it stiff enough?
Right. Yep. Yeah, so any advice on how to do it? Right. Yeah. Yeah, we're working. Yeah, so grants, this is a huge part, so oftentimes the manufacturers, they can deploy a certain amount of capital, and, having a local glulam product may not be where they jump to immediately. So helping to incentivize that process, it could be a good decision, but it may be a better investment for the regional forest economy than it is for the specific business. So it can help the forest industry in the region, but not necessarily the business as much. So if we have grants that can sort of help mitigate that downside risk where they only have potential upside, then it makes it a much more compelling investment for them. So grants are really important, just making sure it's the same production methods, not changing anything in terms of the lamb stock and supply, having additional markets. So, we're trying to do similar things with cross-laminated timber. And so having that complementary product, just allows the suppliers to have more confidence in wanting to supply these markets, if that makes sense. So for instance, the challenge we have with Eastern Hemlock CLT really is that we don't know when the next Eastern Hemlock CLT building is going to be built. So whoever's providing that lamb stock, there's some amount of loss of Eastern Hemlock as it's being dried. They need to overestimate what they're doing for a specific job, and they'll have extra material, and that's just a loss for them, if that makes sense. By having another market, then they can have extra material because they can sell it to the glulam manufacturer. They could sell it to the next building and so on. So Eastern Hemlock's a good example where, if you have these additional markets, such as glulam and CLT, you can have that product develop with less risk, less cost. And then, just making sure, more demand in all preferred grades, so that's important, though, again, it's the low grade issue, so I'm not sure the low grade lumber gets into it. And then an important part is making sure it's a compelling case for them. I find again and again, I often go to someone, that has a forest products business, and it's like, hey, you should do this, because it's good for all of us, but it has to be good for the business. That's where it all starts. And then create a structure where that business is incentivized and all of us can come along for the ride for the greater good. And making sure it's timely, and that's something Lance and the Conservation Fund's been incredible about, and I'll let him talk a little bit more. But oftentimes with some of these businesses, there'll be a discrete point in time where they can act to capture a market, to do something. A lot of grant cycles work on 12 months, 18 months. So it's like, Andy, we could do X, Y, and Z right now if we were certified, in the next 3 months. And it's like, well, it'd be nice if a funder recognized that, and then, you could act on it as opposed to saying, well, let's check again in 18 months or 12 months. But it's happening, so we're moving forward in terms of, glulam with local species, and I'll pass it on to our next speakers to talk more. Thanks.
Fake microphone.
Yep. Yeah.
See, we're going like this. Well, thanks, Andy. Get some slides up here, but my name is Lance Gloss. I'm with the Conservation Fund, and we are a dual mission organization focused on land conservation and economic development. And the vast majority of my coworkers are real estate specialists who focus on the conservation side of that equation. So across the country, over the last 40 years, we've conserved 9 million acres. About 1 million acres of that is working forest land, and about 1 million acres is here in the northern forest region. My mandate within the organization is to maximize the economic value of that conserved land for regional economies. And so oftentimes that means working with the forest products sector, but we also work in a lot of the adjacent kind of social infrastructure issues, housing, childcare, and issues like that. And our goal is really to address the full suite of conservation and economic development concerns that underlie the kind of condition of our rural economies nationwide. So a lot of the work that I'll talk about here obviously is focused on forest products and focused on really New Hampshire and Maine and Vermont to some extent. But we're doing similar work in West Virginia and in Georgia and Washington, other parts of the country, really focused on stimulating a lot of the same progress. So this is a great graphic from Business Oregon that just speaks to the forest products value chain. And our work through our Natural Resource Economy program, which is our rural development program, is designed really to span all of this. And I think this work on glulam and CLT in New Hampshire really speaks to that. I would add, if I was going to amend this graphic, I'd add an arrow coming out of construction and plugging back into a lot of these things. Because when we approach this issue, one of our top line issues is also workforce conditions, right, and how we're meeting housing needs. So I'll touch on that in a moment. But really what we're talking about is how can we make strategic investments, small grants, technical assistance, capacity building in this sector so that we can improve the value capture across all of these stages in the value chain. And in this case, what we're talking about with glulam has obvious implications for forest management, right? Different species, lower value species, also, smaller diameter logs, also, from a milling perspective, manufacturing perspective, obvious plug in there. And then I'll talk a little bit again about how we're thinking about this from a housing perspective. But what we've done specifically in this context, right, is provide a few strategic small grants to allow for certification of local species, right, in glulam and CLT, so specifically SPF South, right, and Eastern Hemlock. And our interest in that respect, right, is to kind of break out of that chicken and egg cycle and provide a little bit of extra incentive that bets on the regional economic impact of all of this, right, and takes the burden off of local businesses that are having to bear that cost. So it's relatively, straightforward logic. I think what, from our perspective, makes it even more compelling, right, is how do we pair it with other strategic investments in the local forest products economy. So this is kind of a template that we've pursued not only in New Hampshire, but as I mentioned, Washington and Georgia. Also investing in the workforce development side of the equation. We've been working with the Project Learning Tree, New Hampshire Timberland Owners Association, to upgrade their workforce development roles and really focus on some of these next generation jobs in forest products. And then also working closely with housing developers. We've got also a keen eye on this Timber for Transit grant and other infrastructure funding that's unprecedented level from federal sources to specifically incentivize developers to use local species, right, and to integrate these new products or really old products that are now catching new attention for good reason into their designs. So at the same time that we are kind of subsidizing that certification process, we've also been paying for design and engineering for housing developers in New Hampshire to incorporate more of these products into their designs and hopefully grow not only that pipeline, but also their familiarity. I think one of the things that we run into a lot with developers is they kind of have their recipe, right? And things like modular housing construction, which is increasingly using CLT, is just a little scary, right? And so even though that industry is trying to figure out what they're going to do to keep costs down, and we work with them on the real estate side of that as well, it's really helpful for them to just get a little jolt, a little financial incentive to engage with these other products. And so as we look forward to the kind of large tranches of federal funding that are coming down, we're interested in not only supporting with these kind of precursor grants, but also with helping to author grant applications and support local businesses, local developers in accessing those funds. So this is a genuine pitch. If you have a project that you think fits that, we'd love to talk to you about how we can support financially or from a technical assistance perspective. We're just really excited about what we've been able to do just to manage some of the risk with these CLT and glulam investments. So here's some of the hemlock drying. We just were able to cover at a really fast pace some of the extra lamstock volume that was needed as kind of a contingency amount in this project. So here you can see some of it drying. And as Andy mentioned, I think one of our key approaches here is to be really flexible and rapid with our response. And so we just build relationships with Extension, with NHTOA, right, and with private businesses, so that we're on call with grants from $15,000 to $50,000 that can be really responsive to opportunity, because this stuff moves really fast, and frankly, it's just not viable to wait for 12, 18-month grant cycle. And so the funding that we have, which is part of our revolving fund from our larger conservation portfolio, we have a lot of flexibility to move quickly on that, and we see that as a huge value. And this all adds up to our broader vision. And so I'll just quickly mention that, forest products is just part of that picture we think of as the natural resource economy. And we're working across all of the sectors that you see there, clean energy, food systems, housing and infrastructure, in all of the geographies where we have an extended conservation footprint through our working forest projects. And we think that's important for a couple of reasons. One is because all of those sectors are critical in and of themselves from a rural development perspective, but also because there are obvious overlaps as we build relationships, not only in housing and infrastructure, downtown revitalization, but even in food systems and energy, right? There are direct plug-ins for forest products, as well as with the, obviously booming recreation sector right now. We're very interested in how we can improve compatibility between land that's under active management and that's in trail use, right? So we see this as just a broader suite of rural economic development investments that relies on that connectivity and then that pace. So that's all for me. Happy to take any questions, or I'll hand it over. Yes, sir.
Historically, there's been reluctance on the part of architects, engineers, insurers,
Yeah.
regulators, zoning people,
Yeah.
to allow use of greater use of wood.
Absolutely. Well, and I'm gonna cheat. I know that Andy had one of his questions written down. I saw it, and it was, but I'm gonna cheat on it with this. Is that's spot on. And if I was gonna cite one major challenge for Glulam, CLT, it is building codes, right? It's code administrators. It is the zoning requirements, right? And then it's builders, even when it's legal, right? There's that level of discomfort. And so engaging with code revisions as we go through the next IBC process and IRC process, like that's going to be critical. And then frankly, incentivizing builders to take that leap by saying, hey, we'll cover a difference in your design cost. Like if you think this is going to cost you, an extra $30,000 or $100,000 in engineering costs for a major housing development, we would buy in to help them get over that gap. But I 100% agree. Absolutely.
Just as Chris takes over, and steps up, I just want to add as well, like we talk about subsidies sometimes, either or at least in New Hampshire. But the goal is not to just provide subsidies indefinitely. There's a new product, there's real costs and risks associated with trying to use it for the first time. So it's mitigating those initial risks until the product sort of takes hold, folks have gone through it, and there's some economies of scale. And so the point's just like, some upfront investment that pays off and then it stands on its own.
All right, thanks. My name's Chris Stearns. I work for Hanson Bridge. We're a small bridge company in Springfield, New Hampshire, so we're not actually here in Vermont, but just over the border. And we've been doing bridges for 20 plus years, a lot of small bridges. And we're trying to, let me see, is this right? That actually picture that you had before is, I think, our machine. This is just in a kind of showing the whole setup, kind of show you how the process works. Basically, this is a Doucette press, it's called, and the lumber is just fed in from the end. We typically use 2x6s, and this is it's a pretty simple machine, really. We're just basically doing straight stock. We don't do any finger joining, so we're kind of limited by the size of the press and also the availability of the timber. It's kind of hard to find 24-foot 2x6s that are much good. So what we've got right here is just an example of a 12-foot long beam, and it's a 4-foot press, but this ultimately ends up being, it's 30 boards, so we're about an inch and a half, no, 3 inches short, just because everything's bowed and to get the glue and everything in there. So basically, the boards come through. That is a glue head that it rolls through, and it automatically applies the glue. We use a 2-part structural adhesive from Loctite, and it's Henkel is the company. And basically, you have to do, there's a lot of different steps involved. You have to weigh your glue. So you do some test runs with it's this little process we do where you weigh the actual glue, and that helps determine your set times. So once we get it all fed in here, you basically just turn on the press. And this press is great. It's actually 2-sided, so you can do the same thing on both sides. And it allows for adjustability here. Each one of these is an individual hydraulic cylinder. So you basically just open up whichever ones you need to apply pressure to the wood. And then you leave it there for a couple of hours, and then you can release the pressure and remove it. We've got this 2-ton crane installed, so we can actually, pick those off of there because they're each board's pretty light, but that thing's pretty heavy. And so in the past, what we've done is use just pressure-treated woods. We bought pressure-treated 2x6s, and we actually drill holes and bolt them together with through rods in 4-foot sections. And so you're basically just buying that stock. And what we decided we want to do is kind of, do this process ourselves. So we kind of control these, these items, and you can do it more economically. So we're getting the just kiln-dried number 2 and better boards. And we can actually do 4, 6, 8, 10, or 12 on this machine. And this particular setup here, this is actually used, so basically if we're using this little block here, it's set like this across steel stringers. So this is kind of a different setup. So we can do 12 to 20, or any width up to 24 feet wide. And with those steel stringers, you can go up to, 60 feet long. So you can do some pretty good sized bridges. But, the timber in that situation is only used for that deck, which, it's not, it's structural in that you can drive over it, but the steel is doing the main work there, supporting the load. And we also have a pressure treating vessel. That's what that submarine looking thing in the background is. And so ultimately, we're still in the process. We're waiting for a new door. But with that, we can actually take our bridge decks and pressure treat them after the fact. So you're not trying to use one board at a time that's already pressure treated. You can feed that whole thing in and pressure treat it. So we'll be able to control that as well. But also, we can pressure treat for other people. So that's why, we're talking about using the local species. It's pretty exciting because we could use it for basic things like this. We can treat individual 2x. We can do a lot of different things with that. And down the road, we want to be able to do more of the, the bridge decks that are purely just all timber. And those, you're kind of limited in length. We'd be limited to 24 feet in actual bridge length, but you can do a foot thick. So you'd be doing 2x12 stacked up the same way and laid on there. And then that would just be your bridge going lengthwise. And that's structural. So you can drive right across that. And you can also do timber rails. And, so like this is not a great picture, but basically one of the things we're doing too is a kit we're going to offer. And so this will allow us to not just do local jobs, because we do design, engineering, installation on the local jobs. We've done most of our works in New Hampshire, Vermont, a little bit into Maine. But by doing this, once we get the wood certified, we can actually ship these all over the country. And basically, so that's kind of what our goal is to be able to kind of mass produce these 4-foot by 12 to 24 foot long bridge deck panels and ship them as part of a package. So I think, ultimately there's potential for some good volume. So that's kind of what we're doing. And this is just an example of what these galvanized steel stringer bridges look like, where you see the ends of the boards. That's really all you see on these ones. You can utilize wooden rails to get a little more wood involved. But this is actually we sell a lot of these just in this, we do 10 to 15 a year just in New Hampshire. with a couple into Vermont too. This not so nice weather has been actually helpful. I hate to say it, but these little residential bridges and things. Yeah, and it's something that can be, you know, that's one of the benefits of this scenario. We prefab as much as possible, so we can basically come in 2 to 3 weeks, put a bridge in. And that includes pouring footings if necessary, or abutments if necessary, depending on the load ratings and what's there existing on site. So, you know, so it's a pretty, this whole kit concept is pretty exciting, and I think working with the local species, I think it's got definitely the potential to be something, but.
So, yeah.
What local species are you using?
Oh, well, we're not yet, that's the thing. Right now we're not, because it's not actually certified. What is the SPFS? Yeah, because the hemlock requires knifing before you pressure treat it, and we don't have that equipment. So there is that potential though, and that's, you know, some of these grants and things, looking at down the road, making things a little more, you know, we can get into a little more complicated items, like we get into some planing. Because right now, these just come out and you can lay them down, and you can either just do a wear coat or pave over them. But, you know, ideally you want to get into the architectural stuff, but that's going to require some more advanced equipment to do the planing of the surfaces to get that architectural grade. So that's the plan, hopefully.
How does the SPF take preservative? Like, I've heard that southern pine like soaks it up really well.
Oh, it does, yeah, for sure.
To incise it to do it. Is it
Right.
comparable to southern pine in observing, or are there different issues?
No. It should be about the same as far as absorbing the materials, but it definitely,
SPF, I'm thinking spruce, pine first.
yeah.
Pine, eastern white pine? All right, so eastern white pine's out of the picture.
Yeah, I mean, I'm not sure how that,
All right. I
as
mean,
far
that's
as what we're
a
doing.
big component
Yeah.
of what grows here.
Yeah.
The higher market value for white pine is the aesthetic, the structural aspect.
Doesn't treat well either.
Okay. Yeah, so that's the sort of thing where they've looked at that a bunch, you know, and the design values are less, the cost is more just for the raw material because it has higher values, and then also you get into things like, you know, most of our pine mills are cutting 1-inch boards, so you need to start, you know, they're really shifting what their market is, and those are the kind of things that can be huge barriers. So it's, you know, if we can take existing dimensional mills doing 2x6s or 2x4s or whatever, and just provide one more outlet or something very small for them to adjust in order to access a new market, that's kind of the first step.
Yeah, we're right across the street from Durgan and Kroll, and they're just doing 1 inch.
Yeah.
All they do is 1 inch trim. But they're literally across the road from us.
In Maine, a lot of the dimensional mills don't want to process red pine because the lumber markets look at it and they think it's something wrong with it.
Yep.
But that can be an opportunity to get those processed and use them in applications like this, because
Yeah.
it does treat well.
Yeah, and we actually do, in our area, there's a lot of more demand also around on Lake Sunapee. There's a lot of money on that lake, and the people don't mind spending more. I mean, I think the whole, grown in New Hampshire, it's like, there's actually some value to that with some of these customers we've got.
It's gotta be pressure treated to do what you're doing,
For this, yes.
any of that.
Yeah. And one of the good things about wood is that it's people are a lot of times like, well, is that strong? Does it last? The salt doesn't affect it, which is actually a big thing with the bridges, because the salt breaks down the concrete. So we'll pull decks off of bridges, concrete bridges that are just all falling apart underneath the asphalt or whatever it is. But the pressure treated wood, it lasts a long time. So I think wood's.
Chris, correct me if I'm wrong, but I think with getting certified for SPF South, with Glulam, you would potentially be opening up a new market for yourselves for building construction.
Yes. Yep, exactly. And that's something as well, like when we get into some more equipment, we could do columns, more decorative elements and stuff used in residential construction that's prettier. Because right now with what we've got, it works great, but it doesn't have that visual appeal that some homeowner is gonna want in their high-end house, but ultimately, yes, that would be the goal.
And so for us, it's really exciting. It would be great to have a big CLT manufacturer, lots of glulam happening, but also the idea that there's smaller manufacturers getting into this, and we're just seeing a smaller business that has a lot of growth opportunity. And so whereas before we didn't have any glulam or local species, now suddenly we do. So it's great to have someone open to doing this that wants to do it, but I'd also say, and correct me if I'm wrong, part of the reason you are doing it is because, there's some degree of support and,
Yes.
some financial support.
Yep, yep.
And otherwise, it may not be the best, choice in terms of where you want it.
Right. And, obviously it is nice to, like you said, it's ideally we'd be using the local species, but having that incentive to, get into that, the cost of the entry with that equipment is kind of prohibitive. So,
The company in New York. They're called Uniland.
yeah, that's Unadilla, right?
Yeah.
Yeah, they do a lot of, we actually toured their plant a couple years ago, and they do some really impressive stuff, but a lot of it's by hand and that there's not a machine that presses it. You got guys with clamps setting all this stuff up, but they'll do the big curves and everything else.
New York, Spruce or Southern Pine?
Yeah, and if anybody's ever coming down 89, you're welcome to swing in and I can show you around, you can check the place out, see some of the equipment. It's kind of cool to look at.
And I should also just mention, we have some of our main friends here, and a lot of, so much of the research, we're the beneficiaries, everyone in the region, of all the great work that they've been doing for decades, So right now with the composites lab and all that, but I think, Shane could probably, the whole presentation on, the catalog you've already done and stuff.
A whole pile of R&D around the late 90s, early 2000s on hemlock and SPFS, layups, glulam, and then reinforcing with structural fibers as well. Those were for infrastructure, bridge beams and things like that.
Oh, wow.
And so, there were some bumps in the road, I think, in the past, but same deal, sometimes it's nice to come back to these ideas. There's different markets, different situations, and it seems to be working at least, we expect some manufacturers to be able to do it.
A lot of times it's just finding the right market niche, What we were working with, the market niche of going into federal highway infrastructure wasn't the right niche. So, but something like this definitely.
Yeah, the federal projects, we avoid that.
Yeah, FHW.
Yeah, it's amazing how much, avoid that
The thing that
stuff.
I'm a small town. And the challenge that I see in this industry is the home for the lower grade wood. And what I'm hearing all about right now is number two and better, which for the most part has pretty good markets. The big thing, what do we do with our challenge is, that lower grade home, because that's a part of every log that comes.
So the lower grade, is that a structural, see, you gotta, pardon me, I actually come from a background of mostly concrete. I'm kind of more new to the wood stuff.
Right.
I know, boo. That's why I used to do architectural precast. But
All
but
the
if,
species are gonna have a whole range.
but with that lower range though, is it a strength issue or is it mostly visual?
It's probably got both. Right?
Yeah,
Right.
because if it meets requirements, these, especially for this kind of thing,
Yeah.
you're just seeing the ends. It doesn't matter
Right. No,
what
I
it looks like. So,
assume yours theoretically isn't as fussy.
right. Yeah, as the other, as
As
the,
these other ones.
yeah.
Because you're laying right up there near, that's decking.
Right. You're looking at it.
That whole bridge.
Part of it too, with building codes, like for construction, number 2 or better is what you have to build.
Right.
So if he saw and he's got, say, a good portion of number 3,
Yeah,
the market value that's very low compared to something.
right.
Build a house.
Right, or, right, the pine, the eastern white pine market, of course, anything that's the higher end is usually always got a good home, it's always.
Yeah.
The lower end struggles, and that's the key right now.
The naughty pine of the 1960s, get that back again. So, we have another, sorry, we have
I
another
had a
question.
question for Andrew or Ricky. I mean, is anyone, we're talking about the lower grade lumber, like, you know, is anyone looking at using the lower grade SPF as the interior lamps on a beam blue lamp? I mean, the places where you don't need the high grade lumber, and then, you know, maybe you bring in some better stuff for just the tension lamps. But, you know, the bulk of the volume of that blue lamp beam, whether it's balanced or unbalanced, is all the layers in the middle, and you don't need the high quality. Is that something that we can provide, or is anyone looking?
I don't know that, I mean, I think it's going to be part of the conversation as we look at certification locally. So I think it's a viable option. I think you do still need to have a structural grade assigned to each of the laminations, right? So if you could get a, say, number 3 grade, potentially that could be used. It's not one of the existing blue lamp lamps now, but you can always certify a new blue lamp lamp. So it's feasible as long as it is able to be graded and has a structural value. The lower the value is, the deeper that beam is going to need to get if it's a beam. So that,
Even for the interior laminations, where it's more covered by shear than.
yeah, I mean, potentially, if you're able to go to very high strength tension laminations, for example, it would have nearly as significant of an impact.
It's mostly space filler, and that
Yeah.
would be the high tension lamp.
There's
I mean,
that.
Not in the decking application where it's, you know,
Right,
arranged vertically, when you're horizontally.
sure.
You should be able to accommodate the low material in the middle.
Yeah, so I think it's viable. I think, like I said, you're probably going to be capped at number 3, you know, because that's basically the lowest you can go and still get a structural property assigned to it.
And also just, yeah, we're constantly talking about how to use lower grade lumber, and then 90% of the time, you know, realize how bad an idea it is, you know, get laughed off. But, you know, you always go there first, you know, how do we get low grade material into this? How do we make it viable and so on? So, yeah, that'll be part of this discussion as well.
Right, because it's good to turn, you know, I could envision lower grade material, you know, you'd have to go through potentially a finger joining process, chop out the bad, and put it all back together again. Of course, that pushes your raw material right back up.
Yeah, yeah.
We're gonna, yeah.
So, yeah, I think, you know, sort of that crawl, walk, run, same thing here. Like, we're at a crawl spot, but at least we're crawling, you know, we're at that spot, and we'll see how far we get to go. So we're going to have more structured questions, but I think this is much nicer. I think our session's finishing up. Are there any kind of final questions for anyone?
Can you send it to Canva?
Yeah, Marina?
I'm curious if you can talk about, I know this isn't a session on workforce, but that seems to be a challenge here, along with like insurance and all of these things, is adoption and having the right structural workforce components to make it happen and not have blue laminated timber that's installed upside down. So just curious if you can speak to that and maybe what work UNH and Humane are doing to make sure that we have the workforce and educated people ready.
Yeah, so I'll just speak real quickly, and then if Shane wants to hop in, but, you know, Maine's doing all sorts of great stuff. I think for us, there's a lot of different separate, so there's a bunch of different audiences, at least the way we're looking at it, that we're trying to engage with different kind of levels of services, so to speak. So, you know, getting young people exposed to the forest industry, either so they're just literate in terms of what that is, or if there's an interest, you know. So there's a bunch of different workforcey type things there. Then there's different, for people who are interested, different levels of investment, so job shadowing type things. Internships is kind of a more committed, you know, investment of those folks. Apprenticeship is an even longer Department of Labor apprenticeship for different positions. Then there's different workforce programs, and, you know, other nonprofits are doing work. So I think what we have right now are a lot of different efforts from different groups, and over the last, you know, number of years, but really more recently, trying to really work together and communicate as much as possible where all those different efforts fit in and how they create these different pathways, so we can collectively try to prioritize and get funding for those, the most critical needs and what's most impactful, and sort of build it out. So that's kind of where we're at. I think one of the fundamental challenges though, so it's communicating a bunch of different groups, so on. One of the challenges we encounter is profitability, or at least that's what I see, is if you have a high value product you're selling, you have a high profit margin, oftentimes you can pay your employees more. Sometimes we go to a lot of conferences, things like that, and folks will go, no one wants to work anymore, nobody wants to get paid $10 an hour, in, conditions, without air conditioning or anything, they're so lazy, and I think we'd get a lot more workers if we were paying them competitive wages or more than the alternative options they have. But sorry, go on, Shane.
Yeah, that's the race to the bottom. If you're trying to sell the cheapest commodity product, there's always going to be a cheaper person out there to sell it cheaper than what you can, and then you're just losing any potential you have. Nobody wants to work in a company like that. It's kind of a death spiral. The educational side of things, we've been working on career pathways with Maine for several years now. A lot of it is students not knowing what is even in their own communities for potential careers. We don't want our kids to leave our communities because they're the future leaders of our communities. Everybody's going to age out and the community dies if all the kids leave. So teachers and students in a school, three buildings over is a small, they don't know anything about it, and that's a problem. We've lost a lot of those community connections and people knowing what's going on in their town. So trying to rebuild some of that. On the higher educational side of things, community college system, we're trying to build some of the mass timber knowledge in there. We did a study. There's no mass timber education in any of our community college systems with the MEPs or in the construction management folks. So there's zero familiarity with it, zero knowledge, zero exposure. There's some programs and pieces within the University of Maine system, but it's all very disconnected and not kind of holistic. So we're actually trying to do some more things around, creating more of the coordination around those pieces so that people understand and can actually build skill sets that are going to go out and be used in the workforce rather than just little pieces of the pie. And just in the shift of how we message, we had a wood science program for decades. Now it's called Sustainable Materials and Technology. Resonates with the younger students. I'm a wood scientist, but I can't say I'm a wood scientist anymore. I'm an sustainable materials. Yeah, exactly. It's like I still do the same thing, but it's been rebranding. Yes, exactly. So
The carbon printers.
right, and Gen Z really does care about things. They want to do a job that means something. They don't want to just have a job. So if you're doing something that means something to them that resonates, they'll be a good employee. It's just that they want something that actually matters, not just a job.
So we're overdue. Thanks for your patience and staying a few minutes longer, and we're here for questions the rest of the day too if you want.